this episode of Finogric Machining, we are going to make a few T-nuts for this new for me rotating table. So, what we are going to use as a material is this Uddeholm Sverker 21 tool steel, which is, it's tough stuff. And then we are going to heat treat them and anneal and everything that. And this is all about this episode. It's a short and the subject is T-nut. Well, this piece here is a Sverker 21 tool steel. The nuts I'm going to make will be 10 millimeters wide, and this is quite exactly, I believe. Let's measure it one more time. But I believe this is really like 10 millimeters. Let me see. Yeah. So it's 10 millimeters wide already, so I don't need to mill the width of that. So all I need to do is to make it flat on top and then mill the grooves, mill the sides off. So then we get a T-nut, and then I will actually use a slitting saw to cut it off. And after that we will drill a series of holes into it, drill and tap them, and after that we slice it into several T-nuts. That's it. So, and I'm using here a special tool. I'm just trying this out. I have never tried this tool out before. If you can see, this is a little bit special. It will run like counterclockwise. Let's see what it does for the sound of our machine. I believe it will sound less horrific. Okay, so now we will start milling this one. I ended up drilling and tapping the M6 threads to the nuts of the camera. Sorry about that. The next presentation is all about Sverker 21, which is a very good tool steel from Sweden. I have no economical relation to the Uddeholm company. I just give the credit to a good tool steel they produce. The steel grade was developed around 1930, so it is over 90 years old. Sverker 21 is a high carbon, high chromium tool steel alloyed with molybdenum and vanadium. It is recommended for tools requiring very high wear resistance, combined with moderate toughness. Here are some examples of its recommended uses. This tool steel is a total overkill for my humble tea-nuts. I am not doing the hardening process strictly by the book. Actually, this tool steel is very forgiving on hardening procedure. If I would aim to a known, constant hardness, I should look into this table and follow the procedure. The maximum hardness is obtained by heating the workpiece to 1030 degrees Celsius and holding it at that temperature for 30 minutes. Obviously, I'm not following that procedure, and for this reason the hardness of the nuts is not constant or known. However, they will become hard and tough enough. In this curve you can see that there is an optimal value for austentising temperature. For Sverker 21, that temperature is 1030 degrees Celsius. The temperature I can obtain using this butane torch is around 1100 degrees Celsius. I keep the workpiece in the flame until it has reached its maximum temperature. I do not hold it in the flame for the required 30 minutes, that would be insane. It seems to become hard enough, even with a short exposure to the austentising temperature. Heating inside a flame has the benefit of somewhat keeping the workpiece from oxidizing. Heating in an oven oxidizes the outer layer of the workpiece quite badly, and there will also be some carbon loss. This does not happen with a flame, as there is less oxygen available. Quenching is the part of the heat treatment process where the workpiece is cooled down fast enough so the internal structure of the metal does not have time to reorganize itself. Quenching of Sverker 21 is not critical at all. It is sufficient to drop the workpiece into oil and that's it. There are more sophisticated quenching methods, but quenching into oil is available for a hobby machinist like me. I am using rapeseed oil, also known as canola oil. This oil will leave a nice coating on the workpiece as some of the oil polymerizes on top of the workpiece due to the high temperature. The canola oil has a pleasant smell, much like baking donuts. The next step will be to temper the workpiece. During tempering, some of the hardness is drawn back, which will add to the toughness of the workpiece. Without tempering, the workpiece would be extremely hard, but really brittle to the degree of not being usable. Tempering will take some time, so I do it using my heat treatment oven. Since the tempering temperature of Sverker 21 is reasonably low, the tempering can be done in a normal kitchen oven as well. Tempering is done in 2 identical steps, each taking 2 hours to finish. Between the steps, the workpiece should be cooled down to room temperature. With Sverker 21, it is imperative not to raise the tempering temperature too high. Raising the temperature too high will make the workpiece too soft. For this reason, tempering should be done with good temperature regulation. I am against using the color change of the material to determine the temperature because it requires to clean up the workpiece to see the color, and it is also much too inaccurate for this process. Holding the temperature for 2 hours would also be challenging without some sort of an oven. So, oven it is. The final hardness of the workpiece is determined by the tempering temperature. Luckily, Sverker 21 documentation takes the ques out of the ques work here. With that graph, it is really easy to determine the final hardness of the workpiece. After 4 hours of tempering, the nuts are ready to be used. Okay, 9 T-nuts out of 10. One was ruined. Well, actually what happened was that I drilled the hole in the wrong place and it poked from the side out. Well, there isn't much because it's M6 thread and the width of this small thing there, it's only 6.6 millimeters. This way it really it has to be in a correct place. Anyway, 9 succeeded, 1 went berserk. And well, that's it. So, and let me see, well, I cannot see it. I have a table down there, but let's see if I remember these correct now. First of all, this Sverker 21, which is a very good tool steel, can be hardened really hard. And it has to be annealed in 250 degrees to get it also tough. So, well, that's it. In the next episode of Innovative Machining, we are going to use that rotary tape. Till then, bye!